Now, today we will discuss about friction. What is friction? Suppose this is a body, its weight is double. A body is resting on the plane, its weight is double. The weight is always acting material downwards. This is normal action Rn, normal to support. Clear? This is applied force P, applied force P. This is frictional force F, frictional force F. Clear? Now I will explain what definition of friction. What is friction? When the surface of another body or one body slides over the surface of another body. Suppose this is one body, this is another body. This is body A. Suppose this is body A, this is surface B. Here, body A slides over the surface of body B. So, when one body slides over the surface of another body, the interlocking property of two bodies is such that it opposes the motion of the moving body. Clear? Then this property is called friction and the opposing force is called force of friction. This is definition. When the surface of one body, that is body A, slides over the surface of another body, that is over B. The interlocking property of the two bodies is such that it opposes the motion of the moving body. This property of the body is called friction and the applied force is applied force P and the frictional force F and the force which opposes the motion of the body is called the force of friction. This opposing force is applied force. The applied force P, opposing force F. Okay, what is the example? Walking on the road. Examples. Walking on the road. Clear? If the road is smooth, our leg can slip, our feet can slip on the road. If the road is rough, we can walk smoothly, comfortably. So walking on the road is also one example of friction. Number two, motion of vehicle on the road. On the road. Vehicle or locomotive, man engine. Clear? Number three, power transmission through belt rope drive. Power transmission through belt, rope and chain drive. Clear? These are the example of a friction. So what is friction? When one body slides over the surface of another body, the interlocking property of two bodies is such that it opposes the motion of the moving body. Body go towards right side, the frictional force is acting towards the left side. This property of the body is called friction, and the opposing force F is called force of friction. Clear? Now, what is types of friction? types of friction. Clear? Friction is made two types. Friction is two types. Number one, static friction. Number two, dynamic friction or kinetic friction. Kinetic friction. Clear? So what is static friction? Static friction. When the body is at rest. Or dynamic friction? When the body is in motion. Clear? So what is static friction? It is the friction experienced by body when at a rest. At a rest. For dynamic friction, this is the friction experienced by body when in motion. Clear? So which friction is more? Static or dynamic or kinetic? This is also called kinetic friction. Clear? So where friction is more? When the body is at rest, the friction is more. When the friction is less, the body can move. Clear? So always static friction is more than kinetic friction or dynamic friction. Dynamic or kinetic friction. Clear? Always static friction is more than kinetic friction. If mu s is equal to mu s, coefficient of static friction. Clear? What is mu k? Coefficient of kinetic friction. Clear? Then mu s is always more than mu k. So what is mu s by mu k? This implies mu s by mu k, mu s by mu k is more than 1. Clear? More than 1. Next, what is dynamic friction? What types of dynamic friction? S is equal to coefficient of static friction. Clear? Mu k is equal to coefficient of kinetic friction. Clear? Then mu s is more than mu k, so mu s by mu k is more than 1. This is about friction. So what types of dynamic friction? Types of dynamic friction. Clear? My handwriting may not be clear to you. Okay. Dynamic friction. Dynamic friction mainly three types. Dynamic friction is mainly three types. Number one, rolling friction. Number two, sliding friction. Clear? Number three, pivot friction. Pivot friction. What is rolling friction? What is rolling friction? When one body rolls over the surface of another body, this is called rolling friction. A ball is rolling over the plane, rolling friction. What is sliding friction? When one body slides over the surface of another body is called sliding friction. What is pivot friction? Due to motion of rotation, a frame is rotating. Due to motion of rotation, this is due to motion of rotation. Clear? This is when one body rolls over another body, over surface of another body. Clear? This is sliding friction. When one body slides over the another body. Clear? This is types of dynamic friction. Rolling friction, when one body rolls over surface another body is called rolling friction. Sliding friction, when one body slides over the surface of another body is called sliding friction. Pivot friction, pivot, rotation, rotational motion. Okay, this is rotational motion. This is called pivot friction. Next, limiting friction. Limiting friction. Okay, what is limiting? Maximum. Limiting means maximum. Clear? What is friction? Opposing force. Opposing force. Clear? So what is the limiting friction? Maximum opposing force. Now I will explain what is limiting friction. Suppose this is body A, its weight is W, normal action Rn. Clear? The body weights W, normal action Rn. Now this body is in equilibrium condition. This figure A. Figure A. Suppose we will apply some force. This weight W. Clear? Normal action Rn. Normal reaction is always normal to surface. Clear? This is Rn, normal 9 degree. This is normal 9 degree. Clear? So, this is figure B. Try to understand. In figure A, W is equal to Rn. In this figure, W is equal to Rn. But I will apply some force P1. Suppose I will apply some force P1. In this case, the body try to move towards right side, but A frictional force acting F1 opposite to the motion of the body, opposite to P1. So in this case, F1 is equal to P1. Clear? And the body is at a rest equilibrium condition. This is equilibrium condition, this is also equilibrium condition. This force P1 balances frictional force F1. Suppose in figure C, this way double 2, this way double O, normal action Rn. Clear? 19. Suppose P1 is increases to P2. Suppose P1 increases to P2. The frictional force also increases to F2. Clear? Clear? Case 1 in figure A, there is no applied force, need not be given frictional force. In figure B, I will apply some force P1. Now, the frictional force F1 balances force P1. Now, body is in equilibrium condition. In figure C, I slightly increase P2. P1, I slightly increases to P2. So, when F4 increases, the frictional force also increases. The frictional force F2 more than F1. So, it increases from F1 to F2. Clear? So, slightly increase of applied force, slightly also increases a frictional force. But there is a limit up to within which the body can be in equilibrium condition. The body can be at rest. Beyond that limit, I will apply some force, body can move. So up to that limit, the frictional force is called a limiting friction. Clear? Suppose clear? This is weight W, applied normal action Rn. Suppose this applied force is P, applied effort is P. So P is more than P1 and P2. So to keep the body equilibrium condition, another frictional force F is acting opposite to the motion of the body. Frictional force is always will be shown at the surface of contact. Clear? So to balance P, another frictional force F is acting opposite motion of the body, opposite to the motion of the body. Now the body is in rest condition. This value of P is equal or less than P, F. Clear? This applied force P is slightly less than F or equal to F. Its value starts from 0 to F. Clear? Now, the body is at rest condition, the body is in equilibrium condition. This value of F is called limiting friction. Clear? So, I have defined what is limiting friction. The maximum value of frictional force which comes into play when a body tends to slide, not slide means dynamic, tends to slide at the point of equilibrium, tends to slide over the surface of another body. Clear? The maximum value of frictional force which comes into play when body tends to strike over surface of another body is known as limiting friction. Limiting friction. Clear? If clear, this is called limiting friction. Now, what is the law of friction? What is law of friction? Number one, what law of friction? What law of friction? Now the body is acting, the force acting towards right side, the body tries to move towards right side, friction is acting towards left side. That means the friction is always acting opposite to the motion of the body. Clear? Number one, the force of friction always acting opposite to the applied force or a motion of the body. Applied force. Clear? Applied force towards right side, friction towards left side. So the force of friction always acting opposite to the applied force. Number two, the maximum value of the magnitude of limiting friction is equal to applied force. Clear? This applied force P is equal to F. Both are nearly equal to each other. Applied force P is always less than or equal to F. If P is more, then the friction is dynamic or kinetic. Clear? In static case, P is equal to or less than F. This is the magnitude of limiting friction is equal to applied force of P. Clear? Number three, the magnitude of limiting friction bears a constant ratio bears a constant ratio to normal reaction. Clear? The frictional force F bears a constant ratio to normal reaction, that is F by Rn. F by Rn is equal to constant. This constant is equal to mu. This constant is equal to mu. Clear? So what is F is equal to frictional force frictional force. What is Rn is equal to? Normal reaction. Normal reaction. What is mu is equal to? Coefficient of friction. Clear? So what is F is equal to? From this equation, what is F is equal to? Mu Rn. Next, number 4. Fourth point. The friction depends upon the friction depends upon roughness of surface. Roughness of surface. Surface roughness. If the surface is smooth, friction force applied is smooth. If the surface is more, then friction is more. So smoothness of the surface depends upon force of friction. Number 5. Friction is independent of area of contact. Area of contact. What is this meaning? Independent of area of contact. The area may be small or large, but frictional force applies. Only depends upon roughness. If the roughness is smooth, it may be less area or big area. The friction will be less. If roughness is more, the area may be small or large. The friction is more. Clear? So independent of the area of the contact surface and depends upon roughness of the surface. Contact surface. Clear? This is about what? Law of friction. Then next, coefficient of friction. Coefficient of friction. Mu. Mu. What is mu? It is defined as the ratio of limited friction to the normal reaction. Clear? That is what mu is equal to F by Rn. This implies what is F is equal to mu Rn. Clear? I told last theory what is F is equal to limited friction, what is Rn is equal to normal reaction. Clear? Next, angle of friction. Angle of friction phi. Angle of friction phi. What is phi? Come to here. Suppose this is surface B, body A, its weight is W, This is normal action Rn. Clear? If applied force P is acting on the body, then what is frictional force? F is acting opposite to the motion of a body or opposite to the direction of a P. Clear? Now, R is equal to W, P is equal to F. The figure is in equilibrium condition. The body is in equilibrium condition. That means this result force Rn, R. Clear? This is result of PAW, this is result of F and Rn. So the result of reaction R, normal reaction Rn, frictional force of F. This is angle phi. This angle phi. What is angle phi? The angle between the resultant reaction and normal reaction is called angle phi. Clear? So now you complete the parallelogram. I completed the parallelogram. Clear? This is R. This is F. What is F is equal to? Mu Rn. Clear? This is Rn. Clear? Now the body is equilibrium condition. At this equilibrium condition, the resultant reaction R makes angle phi with normal reaction Rn. This angle phi is called angle of friction. Clear? What is angle of friction? What is definition? It is the angle which the resultant reaction makes with normal reaction. Clear? So from figure, come to figure. From figure, this angle phi, this is F, this is Rn. Clear? What is tan phi? So from figure, what tan phi is equal to? What tan phi is equal to? F by Rn. What is F? Mu Rn by Rn. Rn cancels each other. So tan phi is equal to mu. Clear? Where mu is equal to where mu is equal to coefficient of friction. Clear? What phi is equal to? Angle of friction. Now, next topic, angle of repose. Angle of repose. Repose. What is repose? First you understand, then I will give the definition. Suppose this is inclined plane, clear? The body is resting on the plane. First understand, then I will give the definition. This way W. Suppose this inclined plane is, this inclined is 5 degree. Clear? English is 5 degree. Now the plane makes 5 degree horizontal. So this balances the horizontal. This nearly equal to horizontal. So when body is resting over the plane, it cannot move downwards because this inclination is very less. Suppose this increases to 10 degree, 10 degree. Clear? At this condition, the body also not move downwards. Clear? If the inclination slightly more than 10 degree, clear? Slightly more than 10 degree, then the body try to move downwards. Clear? When the angle is 5 degree, the body will not move downwards. So this 5 degree is not angle of repose. When the angle increases from 5 to 6, 7, 8, 9, 10 degree, the body has to also rest. When the angle increases slightly 10 degree, that is 11 degree. At this condition, the body moves downwards. So this is angle is not angle of repose. This 10 degree is called angle of repose. Clear? When the body try to move downwards, that angle is not angle of repose. So this angle, which is maximum inclination of the plane with horizontal, at which the body remains in equilibrium. Clear? This is angle 10 degree. This angle alpha. This angle of repose, at which the body is in equilibrium condition. The body will not move downwards. This angle, this plane can balance the weight of the body. This angle of repose. Clear? So, to draw the figure, this is alpha. Clear? Body weight double. Weight body double. Now, this angle is angle of repose, alpha. This is Rm, normal action Rm. Clear? Now, the body is under equilibrium condition. Tell me, what is this angle? 9 degree. What is this angle? 9 degree. This angle 90 minus alpha. Clear? Visual or not? This is 90 minus alpha. So this angle 9 degree. This angle is 90 degree. So what is this angle? Alpha. Clear? Now, body resting in this plane. Always the plane is x-axis. Normal to plane is y-axis. That means this is x-axis. This is equal to y-axis. This is normal. This angle is 9 degree. Clear? Now the body try to move downwards. So the friction will be acted upwards. This F. What is this force? F. What is F is equal to? What is F is equal to? Mu Rm. Clear? This is x-axis, this is y-axis. But W is not in y-axis. W is in inclined force. Here, W is in inclined force. F is on x-axis, R is on y-axis. So resolve W. What this angle? Alpha. So this force is equal to W cos alpha. What this force? W sin alpha. Clear? So first I will define what is the angular repose. It is the maximum inclination of the plane with a horizontal at which the body just begins just begins to slide down the plane. Clear? This means the body is in equilibrium condition. Just begins to move down the plane. Just try to move, not move, or tends to move. Just begins to slide down the plane, or tends to move, or tends to move down the plane. Down the plane. Clear? So in figure, now consider a body resting on the inclined plane, of inclination, clear, of inclination alpha. कैसे कहते हैं? अल्फा. Clear? Let W is equal to weight of the body. Or W is equal to weight of the body. What is Rn? What is Rn? Normal reaction. What is Rn? Normal reaction. What is mu? Coefficient of friction. Clear? What is F is equal to? Limiting friction. Limiting friction. Clear? So in friction, we are considering always limiting friction, because at this limiting condition, the body is at a rest condition, equilibrium condition. So I read this as limiting friction. Clear? So from figure, resolve all the forces, along the plane and normal to the plane, normal to the plane and equating. Clear? Now this is x-axis, this is the y-axis. First I will equate along x, then along y, or along x, y, then along x. Now sigma y 0. y is equal to 0. What is sigma y? What is sigma y? Rn is equal to W cos alpha. What is Rn is equal to? W cos alpha equation 1. Next, sigma x is 0, summation x is 0. What is summation x? F is equal to W sin alpha. Clear? What is F is equal to? W sin alpha. So what is F? Mu Rn. This implies mu Rn is equal to W sin alpha. What is mu? 10 pi. What is mu? 10 pi. What is Rn? What is Rn? W cos alpha. What is Rn? W cos alpha. Your W sin alpha. W cancel each other. So 10 alpha is equal to sin alpha by cos alpha. What is this? 10 alpha. Clear? Now 10 alpha is equal to 10 phi. What is alpha is equal to phi? This means what is this meaning? This means the angle of repose. The angle of repose is equal to angle of friction. Clear? This is a very important question for short question before examination. Next, the minimum force required. The minimum force required to slide a body, on a rough horizontal plane. Okay, find out what minimum force required to slide a body on a rough horizontal plane. This is the theoretical question. This one theoretical question. Suppose this is body. Clear? Suppose this is body, weight double. This is normal action Rn 9 degree. Normal action Rn. Clear? This is applied force P. Suppose this force P makes angle theta with the horizontal. At the same time, another force, frictional force, acting opposite to the motion of body. When the applied force P is a pulling force, pull. So when P is applied towards right side, the body will move toward that side. Clear? So at this point, a frictional force F is acting opposite to the motion of the body. So what is the minimum value of P? Just to move the body. Just to move meaning body is at rest. Just to move, just to slide, tends to slide, equal meaning. This meaning is the body is in equilibrium condition. What is the minimum value of P? I will find out. Clear? Consider a body of weight W. Weight W resting on the horizontal plane or rough horizontal plane. Rough horizontal plane. Clear? Let W is equal to weight of the body, weight of the body. What is Rn? What is Rn? Normal action. Clear? What is F mu Rn? What is F equal to? Mu Rn. What is F equal to? Mu Rn. So where mu is equal to coefficient of friction. Coefficient of friction. What is mu? 10 pi. What is the value of mu? 10 pi. Where what is phi is equal to? Angle of friction. Clear? Angle of friction. Now, P applied force. Applied force. We will find out the minimum value of this P. We will find out the minimum value of this P. Now, resolve P along x-axis, along y-axis. This figure, this is x-axis. This is equal to y-axis. So P makes angle theta with x-axis. So what is the x component? P cos theta. What is this force? P cos theta. What is this force? P sin theta. Clear? P cos theta, P sin theta. Now first, sigma x y is 0. Sigma y is equal to 0. Equating y. Summation y is equal to 0. Now along y, this is upward, this is upward, this is downward. Clear? So Rn plus P sin theta is equal to W. So what is Rn is equal to? W minus P sin theta equation 1. Clear? Now summation of x is 0. What is along x-axis? What the force along x-axis? This is equal to this. Clear? P cos theta is equal to mu Rn. So P cos theta is equal to mu into what is Rn? W minus P sin theta. So P cos theta put mu is equal to 10 phi. What is 10 phi? Sin phi by cos phi. Clear? Now, what is P cos theta? So P cos theta is equal to mu sin phi by cos phi into W minus P sin theta. This is one. Multiply cross multiplication. Apply cross multiplication. So P into cos theta cos phi is equal to W sin phi minus P sin theta sin phi. Clear? Bring P to this side. So P into cos theta cos phi plus sin theta sin phi is equal to W sin phi. Clear? So cos A cos B plus sin A sin B. Cos of A minus B. So P into cos of theta minus phi is equal to W sin phi. Clear? So what is P is equal to W sin phi by cos theta minus phi. This is value of P. This answer P. What is the minimum value of P? We'll find out P minimum. What is the minimum value of P? Clear? How to find out P minimum? Suppose I will give you one example. Clear? Suppose x is equal to 3 by 5. What is value? 0.6. Clear? X is equal to 3 by 10. What is value? 0.3. Tell me which is minimum, which is maximum. In these two examples, this is minimum value, this is maximum value. Clear? So, when the denominator, when the denominator is less, the value is maximum. When the denominator is more, the value is minimum. So, this is x minimum. This is equal to x minimum. This is x maximum value. In the two cases, this is minimum value, this is maximum value. So when x is maximum minimum, when the denominator is maximum. Here also, when the p is minimum, when this value is maximum. Clear? Here, p is minimum when cos theta minus phi is maximum. Clear? What is the maximum value of cos? 1. That means cos 0. What is the maximum value of cos? 1. This maximum value is 1. That means cos 0. This implies cos of theta minus phi is equal to cos 0. Cos cancels each other. What theta minus phi is equal to 0. What theta is equal to phi. Clear? Theta is equal to phi. Now, so to get the minimum value, we'll apply here theta is equal to phi. That means this is equal to 1. Now, what is p is equal to? W sin phi by cos theta minus phi. So for p minimum, this should be 1. This should be 1. So what is p minimum is equal to? W sin phi. Or what is phi is equal to? Theta. W sin theta. Clear? This is minimum value of P, at which the body slides or tends to slide or moves or tends to move on rough horizontal plane. Clear?